In this lesson, we're going to look at the logical operators, which are used to combine relational expressions or conditionals for more complex decision making. So let's take a look by creating a simple little program. I'm going to assign some variables. So I have two variables, grade 1 and grade 2, and I've assigned grade 1 an A and grade 2 a B. So we're going to write a logical expression that says if grade 1 is equal to A, or, grade 2 is equal to A, then write out graduating with honors. And again, I'm just kind of making things up here. There's no real rhyme or reason to that. Now let's take a look at the logical operator. This particular logical operator is OR. So what I want to do is I'm going to add a comment up here. The logical OR is the two bars, which are the shift backslash. And with the logical OR, for the whole expression to be true, either the first expression or the second expression must be true. So in other words, if grade 1 is equal to A or grade 2 is equal to A, then we can write out graduating with honors. So it can be either one. It can be the first one or it can be the second one. Doesn't matter which one, or it can even be both. So let's compile this. Let's close it, and then let's run it. And so we do get the expression graduating with honors, simply because one of those is correct. In this case, it's the first expression, grade 1 is equal to A, was certainly true. Now let's change that to the other logical operator, AND. Let's talk for a minute about that. The logical AND is two ampersands. And in this situation, with the logical AND, both sub-expressions have to be true. So, grade 1 must be equal to A and grade 2 must be equal to A. So let's compile, run the code, and you'll see nothing was displayed. Let's modify that program. So that we can see something here. That's kind of harsh, but we'll leave it there. Alright, so now we have an else, so that if the expression, the whole logical expression, is not true, then we'll see something else. So let's compile. Then let's run the program. So this time we see graduating with no honors. That's because, going back to the code, for an AND to be true, both parts have to be true. So in this case, grade 1 is indeed equal to A, but grade 2 is not equal to A because we assigned grade 2 B. If we change that to where graduating with honors can be with an A or a B, in this case they have to be exactly like that. Grade 1 has to be an A and grade 2 has to be a B. Kind of odd, but let's go ahead and compile it just so you can see. Then you see it says graduating with honors. So to summarize, we have two logical operators, the logical OR the logical AND. With the logical OR, either one of two relational expressions has to be true for the complete expression to be true. And with the logical AND, both sub-expressions have to be true in order for the whole expression to be true. There's a third logical operator, which we won't discuss here, other than just to mention it, and that's not. Let me add that into our comments here real quick. Whoops. And that's the exclamation point. And that simply negates or reverses a conditional expression, so that if you say not true, that's equal to false, or if you say not false, that's equal to true. We'll see other uses of not down the road. You don't really use it with decision making like we're using the logical or and, so I'm not going to go into the details of it now, but I just mention it to be complete in that it's the third logical operator. But the two logical operators we want to discuss in terms of decision making are the logical or and the logical and.